Hi everyone, so this is a lesson on factoring. It's a different type of factoring, but it's going to base off of the same skills that we learned how to factor quadratics back in chapter 2. It's a different way because we're exploring this new vocab word called an identity. It's basically where I can recognize a pattern within an expression, and based on that pattern I can factor it, okay? It's just a helpful tool to help us multiply and factor polynomials. We're going to focus on factoring today. So let's start with a warm-up here on factoring the following quadratic expressions. So it's probably been a while since we factored, right? So I'm going to go over the first one together. Remember, if it looks something like this, x squared plus 9x plus 20, I want to factor it, means I want to get it into this form. Okay, so I'm going to need two numbers that multiply to the c value, which is 20, and add to our b value, which is 9. Okay, so I have two numbers that multiply to 20. Let's think about 4 and 5, right? 4 times 5 gives me 20. 4 plus 5 gives me 9. Perfect. If you didn't think of those right away, like maybe you thought of 10 and 2, well then they don't add to 9, so you have to keep looking. Once you have those two numbers, you're going to put them right into the factored form. So they're both positive, so I write x plus 4, and then I write x plus 5. And that's my factored form. And that's it. So go ahead, guys, and do these other three. So if you want to pause this and make that chart, go and do those three. Okay, so I'm assuming that you just paused this and did those three, and I'm going to show you the answers. Let's see here. I guess make a comment if you have any questions in Schoology. This is usually where I would be like, okay, any questions, guys? Okay, right, so two numbers that multiply to c. So negative 8 times 3 gives me negative 24. Negative 8 plus 3 gives me negative 5. We're just checking. Negative 6 times 10 gives me negative 60. Negative 6 plus 10 gives me positive 4. Negative 6 times 2 gives me negative 12. Negative 6 plus 2 gives me negative 4. Okay, so let's actually factor a little bit more. Okay, these look a little bit different. Why do they look a little bit different compared to those ones that we were just doing? So notice they both have the x squared term, and they both have a plain number at the end. The term that it's missing is the b value, right? Like, where is the term with the x? That's what it's missing. So we're going to do it the same way with the chart, right? But now multiplies to c. My c is negative 9. What's my b value because it's missing? 0, okay? So that's the chart that we need to make. So go ahead, make that chart and factor these two last expressions here. Pause it and go ahead and factor. So assuming that you guys paused it and just factored this, we should have gotten over here two numbers that multiply to negative 9 is a positive 3 and a negative 3, right? 3 times negative 3 gives me negative 9. 3 plus negative 3 gives me 0. So my factor form is x plus 3 and x minus 3. Okay, and what about this next one? What did we notice? Two numbers that multiply to negative 25 and add to 0. A positive 5 and a negative 5. And it doesn't matter the order. Notice the minus, plus, minus doesn't matter. But there's a pattern here, right? There's a pattern between the original and my final answer. Anybody recognize the pattern? Specifically between these numbers, the 25 and the 5 and the 9 and the 3. What we should notice is that they're perfect squares, right? The square root of 9 is 3, and the square root of 25 is 5, and it's always a positive and a negative, positive and a negative. So the shortcut here is that I need to know, or I need to notice, anytime I notice that my numbers are in this form with a perfect square, I'm not going to make this chart, right? I don't want to make this chart anymore every time. I want to just use this little formula here. So write this formula down. That anytime I realize that they're squared, I can just rewrite it as the same exact factor, right? They're the same factors, just one's positive and one's a subtraction sign. Okay? So write this formula down and we're going to do some practice. Okay? The first practice we're going to do is this guy. So the direction says factor the following expression. I'm not going to make the chart anymore. I need to be able to recognize, oh, 16, that's a perfect square. So I'm going to use that formula. What I need to use that formula, though, is I need to find out what A is and what B is. If you go back over here, notice there's an A and a B, right? It's a common mistake to be like, oh, well, B is 16, right? It's not. B is something that's getting squared. So I need to figure out something squared that gives me x squared and something squared that gives me 16. And this is the form that I want you guys to set this up in, so always write this down. And this is what I'm asking myself in my head. So let's do this guy. What squared gives me x squared? Well, that's kind of easy, right? X squared is x squared. What squared gives me 16? 4, right? 4 squared gives me 16. So that is going to tell me what my A and what my B is. I'll make this red. Let's make this blue, green. Okay. And B is 4. So now I can go ahead and plug it right into my formula. This is x squared minus 4 squared equals, my factored form is x plus 4 and x minus 4, where I just plug the A where the x where the A is, and the 4 where the B is, because my 4 is my B. Okay? And that's it. Here's my factored form. Let's look at another one here. Okay, let's look at this guy. At 4x to the 6th minus 16y squared. Okay, we're always going to start off with the skeleton framework where I want to ask myself, what squared minus what squared? Okay, here it's different, right? I have numbers and variables, so we're just going to work with them separately. So first I'm going to look at that 4. What squared gives me 4? 2, right? 2 squared gives me 4. I have to now look at this variable, x to the 6th. When I look at that x to the 6th, I need to remember this exponent rule. This exponent rule is power to a power. What happens when I have an exponent raised to another exponent? We multiply those two exponents together. So here's an example. X to the 4 to the 3rd power, I multiply 4 times 3 gives me 12. So I can fill in like a little x here, right? X needs to be raised to something squared to give me 6. So what times 2 gives me 6? 3. And I can check this, right? 3 times 2 gives me 6. Another way I kind of think about, I go backwards a little bit. 6 divided by 2, if we do division, 6 divided by 2 gives me 3. That goes here. Multiplication and division are opposites. All right, so I'm going to do it again. 16. What squared gives me 16? 4. And what squared gives me y squared? Y squared, that's easy. Okay, awesome job. So let's take a look at, now we have to go and factor it. Okay, it's difference of squares. I'm going to use this formula. Here's my A, 2x cubed. So I'm going to take 2x cubed and put it where my A is, in the first part of both of these factors. 2x cubed plus something and 2x cubed minus something. That something is my B term. So 4y, I'm going to put where my B is. Here is my entire factored form. Okay, so here's 2 examples of difference of squares. Use this video and you're going to go ahead and try some examples in the practice. Okay, so you're going to do these practice ones. Awesome job, guys.